All right, this is the last video for worksheet number 1, and this involves word problems that use the equation distance equals rate times time. So d equals r times t. So distance equals rate times time. Okay, and so let's go ahead and try to give just a few examples for how to work with these problems. And I like to organize my information into a little table where usually we have the name of some of the, well, we'll fill it in just a moment so you can see what I mean. And then distances, rates, and times. And then the bottom I leave as a total column or total row. Okay, so let's read the first problem and then we'll talk about what these names are. It says two cyclists leave the same point at the same time, one heading east at 18 miles per hour and the other west at 22 miles per hour. How long until they are 160 miles apart? So we'll call this cyclist number 1 and cyclist number 2. Usually there's a couple different quantities. You can name them differently. Um, so cyclist 1, cyclist 2. Okay, let's draw a little picture. It's always a good idea to try to draw a picture. We know that north, east, south, and west. Oops, never eat soggy waffles there in clockwise order. So we're told that one is heading east at 18 miles per hour, and the other is heading west at 22 miles per hour. And then we want to know when will they be 160 miles apart. So, okay, let's start with the easier ones because we know that cyclist 2 is going 22 miles per hour. All of these rates in this problem will be in miles per hour. The times then we'll consider in hours, and the distances will be in miles. Cyclist 1, we said, is going 18 miles per hour. And it says two cyclists leave the same point at the same time. So the time um, we can call just, let's call it X to use a different variable name. So I'll label my variable here. X represents the time spent traveling. Okay. So since they left at the same time, they will both have the time X. And now is our where we bring in our equation, distance equals rate times time. If cyclist 1 is going 18 miles per hour and they've been traveling for X hours, then the distance that they travel in X hours will be 18X miles. And just remember, if I asked you how long will this 18 mile per hour cyclist travel in 2 hours, you'd probably say 36 miles. How about in 4 hours? Well, it'd be 18 times 4. So in X hours, it should be 18 times X. Similarly, the cyclist traveling 22 miles per hour for X hours will reach a distance of 22X miles. And we want to know when they will be 160 miles apart. So we want to know when the total distance between them, or the sum of their two distances, is 160 miles. I'll put 160 right there. Many times this, oops, I shouldn't put an X there. This block isn't used here. Sometimes the total time is used. In this case, it's not. So we'll just scratch that out. Okay, but notice that here is the distance that cyclist 1 travels. Here is the distance that cyclist 2 travels. And so we want the sum of those two distances to be 160 miles. So the distance of cyclist 1 plus the distance of cyclist 2 equals 160. miles. So we can plug everything in. Distance of cyclist 1 is represented by 18x. Distance of cyclist 2 is 22x. And the total distance between them we want to be 160 miles. So we combine like terms. This is 30 plus 10 is 40. X equals 160. Divide by 40 on both sides, and we get x equals 40. Now, this is in miles, so this is miles here. And so, sorry. This is in, yeah, let's be careful here with the units. X is actually defined to be a number of, an amount of time here. So this is going to be in hours. And if you want to get a little bit more into the weeds of these units, X is defined to be in hours. This 22 was defined to be in miles per hour. And so when we divided by 40, we really divided by 40 miles per hour. This was in miles. And so when we divided by 40 miles per hour, we're getting miles divided by miles per hour. So that's the same thing as multiplying by hours over miles. And the units of miles cancel, and we get units of hours. Okay, so we have to be a little bit careful here, and we should check, the question. It says, how long until they were 160 miles apart? Well, they're asking for a time there, and that's exactly what we found. So we are done. If they had asked, how far does each person travel until the moment when they are 160 miles apart? Well, in that case, you can find the individual distances here with these two expressions. Okay, but we weren't asked for that, so I won't find that. 40 hours. Whoa, that's a lot of hours that it takes for them to be 160 miles apart. Okay, so I'll write a sentence. The cyclists will be 160 miles apart after 40. Oops. And 40 hours seemed a little bit ridiculous. You can see I'm making a good number of mistakes there. 160 divided by 40 is not 40, it's 4. Okay, so small little typo there. After 4 hours. A lot of times these answers do end up coming out to be fairly reasonable values. But if the answer was 4 or 40 or whatever. Okay. This actually goes again to checking your answer. There was another problem where I had to check my answer because it didn't seem reasonable. That did seem a little unreasonable there. So we can actually check now that I'm not sure if I did this problem correctly. I should check to see if after 4 hours they will be 160 miles apart. So yeah, I was just mentioning that you can check their individual distances with these two expressions, 18x and 22x. Let's go ahead and check that. 18 times 4 and 22 times 4, that is going to be equal to 40 plus 32, which is 72. And then 80 plus 8 is 88. These are the distances that cyclist 1 and cyclist 2 travel. If we add these two together, we get 10, carry the 1, 15 plus 1 is 16, 160 miles that these two are apart. Okay, so we've confirmed that 4 hours is indeed the correct answer. So we will, stop there. For each of these problems here, I will make a separate video for each one of them. So we'll stop there and make sure to like the video.